do some thermal expansion problems. Remember the formula for thermal expansion comes if you have a rod of length L or L naught. All right, and it's at some original temperature T. And then you heat it. All right, then this will be some final temperature, and it will expand some delta L, where delta L is the amount of the expansion and L is the original length. And remember, your delta T is always T final minus T initial. And the relationship between delta L and all of this is the change in length is going to be whatever your original length is, times your coefficient of linear expansion, times the change in temperature. Now, sometimes you're going to want to know what the final length is. All right, what if you want to know what the final length is? Well, clearly that's going to be your original length plus your change in length. So let's see if we can do a couple. A newly developed alloy is tested. A bar of the alloy is cut to a length of 1.000 meter at 10 Celsius. When heated to 100, the length becomes 1.0015 meters. What's the alloy's coefficient of linear expansion? All right, so let's see. This is my original length, is 1.0000 meters. In these problems, sig figs do matter. T initial is 0 Celsius. And then let's see, T final, it's heated to 100 Celsius. The new length is 1.0015 meters. All right, so I don't know delta L on this one. Delta L is L final minus L initial. Isn't that what delta always is? Final minus initial. So this is 1.0015 meters minus 1.0000 meters. So delta L is 0.0015 meters. While I'm here, I'm going to go on and find delta T. Delta T is T final minus T initial. So it's 100 Celsius minus 0 Celsius or 100 Celsius. No, you cannot just say it's 100 and walk away. I need to see your work. So let's see. Delta L is initial length, alpha, delta T. Now I'm solving for alpha right here. So I'm going to divide both sides through by L delta T. So my coefficient of linear expansion is the change in length divided by L delta T. So the change in length is 0.0015 meters. The original length is 1.0000 meters. And delta T is 100 Celsius. All right, meters cancel. What units am I left with? Per Celsius. So this is going to be 0.0015. And then I'm going to multiply everything in my denominator. 1 times 100 is 100, and Celsius stays there. So this is, let's see, 0.00. I'm going to move this 2 more. Okay, to put this in scientific notation, 1, 2, 3, 4, 5. This is 1.5 times 10 to the negative 5 per Celsius. Alphas are very small, and so instead of leaving them like this, we do tend to put them in scientific notation. Now, the Eiffel Tower stands 300 meters tall. I'm going to draw the Eiffel Tower here. Kind of scary. On a day when the temperature is 22 Celsius. How much taller is the tower on a hot summer day? At T is 40. So we're going to say the initial length is 300 meters. T initial is 22 Celsius. And T final is 40 Celsius. And they've told us alpha for steel is 11 times 10 to the negative 6 per Celsius. Let's find delta T to start with. So this is T final minus T initial. So this is 40 minus 22. And 40 minus 22 is 18 Celsius. All right, so delta L is L naught or L initial alpha delta T. The original length is 300 meters. Alpha is 11 times 10 to the negative 6 per Celsius. And delta T is 18. Multiply straight across. You can do this all at one time or one step at a time. When you multiply 300 times 11 times 10 to the negative 6, you get 0.0033 times 18. Okay, so when I multiply that by 18, I get 0.0594. Now, let's see. Did I do something wrong or did I use the wrong number? You never know, because that's different from this number here. It may just be wrong. L is 300, 22 to 40, 11 times 10 to the negative 6. 40 minus 22 is 18. Okay, times 300 times 11 times 10 to the negative 6. Nope, that's the answer I get. So guess what? That answer is wrong. Happens. Here's my answer. Delta L is 0.594 meters. Teachers make mistakes all the time. I'm not worried about it. An aluminum rod grows 0.0033 meters in length when its temperature is raised from 20 to 100. What's the initial length of the rod before it's heated? All right, let's see. Let's start backwards. Alpha is 24 times 10 to the negative 6 per Celsius. All right. And I know it grows 0.0033 meters. So that's my delta L. 0.0033 meters. The temperature starts at 20 Celsius and T final is 100 Celsius. So delta T is T final minus T initial. So it's 100 minus 20 or 80 Celsius. So let's see, delta L is initial length alpha delta T. So let me find the original length. So I'm going to divide through by alpha delta T. So let's see, those cancel. L is delta L divided by alpha delta T. So see, delta L is 0.0033 meters divided by alpha, which is 24, times 10 to the negative 6. And this is going to be times delta T, which is 80. Now, multiply straight across. There's nothing in the numerator, so it's except the 0.0033. So I'm going to carry that. Now, multiply these two numbers together. 24 times 10, ooh, clear that. 24 times 10 to the negative 6, all right, times 80 is 0.00192. Now, when I divide 0.0033 by 0.00192, I get 1.71875 meters. So that's the initial length of my rod. Now, how many sig figs do I really need here? 1, 2, 3, 4. So 1, 2, 3, 4. So actually, technically, correct answer would be 1.71875 0.088. Now, two equal lengths of strips of aluminum and steel are heated. Which expands more? All right. Delta L is initial length alpha delta T. Let's see. They have the same initial length, and you assume they're heated at the same temperature. So which one's going to expand more? Well, clearly the one with the larger alpha. All right. Alpha for steel is 11 times 10 to the negative 6 for Celsius. And alpha for aluminum is 24 times 10 to the negative 6 for Celsius. So which one's going to expand more? Clearly, the aluminum, because alpha is larger. Now, two 5-meter strips of metal, one aluminum and one steel, are the same length. When heated to 200, how long is each? What's the difference in their lengths? Okay, well, let's see. Let's do two columns. They're both, initial length for both of them is 5. And they have the same initial and final temperature. So let me go ahead and do this first. T initial is 20 Celsius. T final is 200 Celsius. So delta T is T final minus T initial. So this is 200 Celsius minus 20 Celsius, or 180 Celsius. So basically, I'm going to come over here and do the calculation. Or let me just do the formula over here. And then I'll break it into steel and aluminum. Let's see. Delta L is equal to, let's see, initial length, alpha, delta T. Now they have the same initial length, different alphas, different delta T's. I could show how the change in length final is going to be the same as the change in length. Well, let's just go on and figure it out. Let's do steel first. All right. I'm going to make my calculations a little bit easier. L in both of these cases is 5 meters. Alpha and delta T is 180. All right. 5 times 180 is 900. So delta L is going to be 900 times alpha for both of these. So for steel, delta L is 900 times alpha for steel is 11 times 10 to the negative 6. All right. 900 times 11 times 10 to the negative 6 is, let's see, 0.0099. So L for steel is going to be the initial length plus delta L for steel. So this is 5 plus 0.0099, or 5.0099 meters. Let me come over here, and I'll do this in brown. For aluminum, delta L is 900, because remember I've multiplied L and delta T. Let's see, for aluminum, this is 24 times 10 to the negative 6. So 900 times 24 times 10 to the negative 6 is, let's see, 0.0216 meters. So L for aluminum is the original length plus delta L. So it's 5 plus 0.0216. So it's 5.0216 meters. All right, what's the difference in their lengths? So delta L is going to be, let's see, L for aluminum minus L for steel, because aluminum's larger, 5.0216 minus 5.0099, and I get what is this? I get 0.0117 meters. Cool. Now, remember what I told you a second ago? I could have taken the difference in these two right here and gotten that number as well. If I did 0.216 minus 0.0099, I see I get 0.0117. All right, but that's all right. I already had the final length. Now, a 15-meter length of steel expands 4 millimeters when heated. What's the temperature change? All right, the original length of steel is 15.0 meters, and it expands 4 millimeters. So delta L is 4 millimeters. Now I have to convert this. I know 1,000 millimeters is 1 meter. So this is 4 times 10 to the negative 3 meters. And of course, alpha is 11 times 10 to the negative 6 per Celsius. So delta L, is initial length, alpha, delta T. In this case, I'm looking for delta T. So I'm going to divide both sides through by L alpha. So the change in temperature is delta L divided by the original length times alpha. So the change in length is 4 times 10 to the negative 3. And I could have left this as a decimal. That would have been fine. Divided by 15 times alpha, which is 11 times 10 to the negative 6. Now multiply straight across. This is 4 times 10 to the negative 3 divided by, I need my parentheses here, 15 times 11 times 10 to the negative 6 is, let's see, 1.65 times 10 to the negative 4. So 4 times 10 to the negative 3, let's see, divided by 1.65 times 10 to the negative 4 gives me, let's see, this is 24.242424 Celsius.